Shortly after the end of the Civil War, with industrialization gaining momentum in the United States and new construction sprouting up everywhere, there was an increasing need for better ways to test the materials used in machinery, in buildings, and elsewhere. Engineers decried the lack of reliable information on the properties of materials. The art of construction is involved in mystery and obscurity, noted Van Nostran's Engineering magazine. The knowledge of materials is at present absolutely empirical. Before the constructor makes use of either a new material or an old one in a new form, the only safe method is to experiment. Without some means of testing the strength of materials before their use, however, these experimental results were likely to take the form of explosions or building collapses. From the 1850s on, various devices for testing materials had been developed, but the goal of a truly universal testing machine proved elusive until 1880, when Philadelphia engineer Tinius Alsson, a Norwegian immigrant who had just lost his job, devised and patented what became known as the Little Giant. Here at last was a machine for tensile, transverse, and compression testing united in a single instrument. Alsson's mechanism was to become the ancestor of all testing machines subsequently produced around the world, while the company Alsson set up to market his invention continues in the testing machine business to this day. Universal Testing Machine, or commonly called UTM, is a general-purpose machine used to check tension load and compression load applied via different fixtures to test materials. Any test material that has elongation or compression properties can be tested in UTM machine. Test sample can be any material, component, or a structure. Universal Testing Machine have two major components: the control unit and loading unit. The loading unit of a UTM consists of the following components: load frame, upper crosshead and lower crosshead, elongation scale. The load frame of a universal testing machine can be made either by single support or by double support. The load frame consists of a table, where the specimen is placed for the compression test, upper crosshead, and lower crosshead. The upper crosshead is used to clamp one end of the test specimen. The lower crosshead in the load frame is the movable crosshead, whose screws can be loosened for height adjustment and tightened. Both the crossheads have a tapered slot at the center. This slot has a pair of rack jaws that is intended to grip and hold the tensile test specimen. The relative movement of the lower and upper table is measured by an elongation scale, which is provided along with the loading unit. The main components of the control unit in a universal testing machine are hydraulic power unit, load measuring unit, control devices. This unit consists of an oil pump that provides non-pulsating oil flow into the main cylinder of the load unit. This flow helps in the smooth application of load on the specimen. The oil pump in a hydraulic power unit is run by an electric motor and sump. This unit has a pendulum dynamometer unit that has a small cylinder with a piston, which moves with the non-pulsating oil flow. The pendulum is connected to the piston by pivot lever. The pivot lever deflects based on the load applied to the specimen. This deflection is converted to the load pointer and displays as a load on the dial. The control devices can be electric or hydraulic. Electric control devices make use of switches to move the crossheads and switch on/off the unit. A hydraulic control device consists of two valves, right control valve and left control valve or release valve. A right control valve is used to apply load on the specimen. The left control valve is used to release the load application. There are many applications of universal testing machine. One is tensile test, for thin plastic films, is done in UTM machine or a dedicated tensile testing machine by gripping clamping the test sample at each end, and is pulled until it breaks. In tension mode, the UTM machine will move in upwards direction vertically. Typically after the tensile test, some parameters like tensile strength, percent elongation, maximum force, etc. are calculated. Compression test. Fixtures called compression platens, of different sizes depending on test specimen, are used as upper and lower fixtures, followed by placing the test specimen between these fixtures and compressed up to certain load or extension, or till the sample breaks. Generally, types of materials subjected to compression test are concrete, metals, plastics, ceramics, composites, corrugated boxes. Seal strength test or seal integrity test is done with a UTM machine to check maximum force required to break a seal of a package. To perform this test, sealing of a package is done by using a heat sealer generally at specific temperature, pressure and dwell time. This test is performed in tensile mode. Final results checked for seal strength test is maximum force. This test is performed to check how much force will be required to open a particular package. With help of this result, the actual seal strength is optimized at the packaging line by controlling seal time, temperature, pressure, etc. The bond strength test is performed with a UTM machine to check the adhesive force between the two layers of any material. Final result for the bond test is measured in the form of average force. Here graph is checked at the end of the test. If the graph gives out uniform force, then it is concluded that adhesive is properly applied to the test material structure, and if any peaks troughs are observed in graph, then it is concluded that the adhesive has not been applied uniformly to the test material. Gliding force test is performed with a UTM machine to check the smoothness between any two surfaces. This test can be performed in both modes, that is tension as well as compression, depending on the test to be performed and the sample to be tested. The best example for gliding force test is when this test is performed on syringes injections in the pharmaceutical sector. In this case, the test is performed in compression mode and plunger will push the head of the injection up to a certain limit. Final results observations are average force in graph, which is evaluated to check in peaks troughs during the test. Puncture test is performed in UTM machine by placing the sample in the bottom fixture, where a certain circular area is secured at the perimeter, and the center area is kept hollow. This is done according to standards. Then a puncture probe is used as an upper fixture, and this probe travels downwards until the test material is punctured. The result calculated is the maximum force required to puncture a material. This result is called as puncture resistance. 3-point bend or bend test is done in compression mode in universal testing machine, where length of material is kept on support at two ends. The unsupported length is defined as per standard, and a plunger will apply the pressure at the center of the material till a certain extension or till it breaks. Final results calculated are flexural modulus. Friction test is performed to determine the smoothness between two materials by sliding one material over another at specified test conditions. Results observed after the test is performed are static coefficient of friction, starting force, and kinetic coefficient of friction, average force while sliding. These results are then related to slip properties of plastic films that are of wide interest in packaging applications. Spring testing in UTM is a very specialized application. Springs can be tested in tension as well as compression mode, depending on the final application of the particular spring. In compression mode, a spring is placed between two compression platens and is compressed till the predefined compression points. Extension. Results measured are 1. The load force at predefined compression points. 2. Spring rate, load per mm. In tension mode, springs are placed in tension hooks and are pulled to the given tension limit. The final result generally observed in this case is the load at the given tension limit. In the food industry, UTM machine is generally marketed as texture analyzer, with some tweaks given especially for the food industry. Food texture analysis can be performed with universal testing machine by using various fixtures available like different variety of blades, different types of probes like ball probe, cylindrical probe and a conical probe, which are available in different diameters. Final results which can be obtained after performing this test are firmness, crunchiness, hardness, extendability, brittleness, gumminess, cohesiveness, stickiness and more. UTM can be used to test a wide variety of materials like concrete, steel, cables, springs, steel wires and chains, slings, links, rope, winches, steel ropes, etc.